Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on December 30th, 2025, just about 6 days ago. It introduces a framework called DualityForge that uses counterfactual video editing to reduce model hallucinations, achieving a relative improvement of 24% over the QN 2.5 VL baseline. The paper is titled, Taming Hallucinations, Boosting MLLM's Video Understanding via Counterfactual Video Generation. And as we'll see later, the way it leverages synthetic errors to improve visual grounding is really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. So Figure 1 gives us a concrete look at this problem using two counterfactual examples. On the left, we see a video edited so that a pile of rocks magically multiplies and grows, a scenario that defies physics. When asked what happens, powerful models like Qwen vs. L and GPT-4o fail. They select the intuitive answer that the rocks stay the same, ignoring what is actually on the screen, because their training biases them toward realism. In contrast, the author's model, DNA Train 7B, correctly identifies the strange event, showing it relies on visual evidence rather than just language priors. Well, Figure 2 breaks down the three editing pipelines used to manufacture these videos. At the top, Pipeline 1 creates basic visual anomalies using standard tools like OpenC versus in the middle. Pipeline 2 focuses on semantic anomalies. It identifies an object, masks it with grounding dyno and SAM, and removes it using a tool called VA-circa-E. Finally, Pipeline 3 generates common sense anomalies, using a model called Flux to synthesize frames that defy logic, which are then interpolated into a smooth video. Figure 3 puts those pipelines into the broader DualityForge framework. Across the top, the diagram traces the flow from real videos through counterfactual generation to the creation of question-answer pairs. The middle section displays the resulting variety, showing visual anomalies like brightness shifts, semantic changes where objects vanish, and common sense violations. Finally, the bottom charts detail the scale of the Duality VidQA dataset, which contains over 100,000 samples for supervised fine-tuning and 20,000 specific pairs for reinforcement learning. Moving from data generation to training, Figure 4 illustrates the DNA Train framework. On the left, the system processes paired real and counterfactual videos for the same question. The model generates separate reasoning paths for each, which are evaluated to compute rewards. The key innovation appears on the far right. While standard training leads to divergent learning signals, the bottom charts show how their normalization technique aligns these signals, ensuring the model learns equally from both real and synthetic data. So, with that training in place, Table 1 compares the resulting performance against state-of-the-art models on the Duality VidQA test set. The columns categorize specific anomaly types, such as causal reversal and counterphysical events, reporting accuracy for real videos, counterfactuals, and the strict both metric. Looking at the baselines in the middle, even powerful models like QN 2.572b show a significant drop on counterfactual data. However, the author's model in the bottom row bridges this gap. It achieves an overall both accuracy of nearly 77%, surpassing the much larger QN baseline and effectively matching top-tier proprietary models like Gemini 2.5 Pro. Alright, Table 2 expands the evaluation to a wider range of benchmarks, covering both hallucination detection and general video understanding. On the left side, focused on hallucinations, the proposed DNA Train 7B model achieves 76.8% on the Duality VidQA test, and remarkably, it scores 61.3% on event illusion. This represents a massive jump over the QN 2.5 baseline, which sits at just 33.5% on that same metric. Crucially, the right side of the table shows that this specialized training doesn't hurt general capabilities. In fact, the model outperforms the baseline on general benchmarks like M versus bench and T versus bench, proving that learning from counterfactuals actually sharpens overall video comprehension. Wrapping up, two takeaways stand out. First, generating counterfactual videos forces models to abandon lazy language priors and rely on actual visual evidence. Second, this confirms that synthetic data is more than just filler. It is a powerful tool for sharpening model reasoning. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.